A hollow spherical ball of uniform density rolls up a curved surface with an initial velocity 3 meters per second. Maximum height with respect to initial position covered by it will be dash centimeter. So now we are given the values. Initial velocity v0 is equal to 3 meters per second, and we have to find h max. So now our ball is initially over here and it rolls up and goes over here. So here the kinetic energy, total kinetic energy in this place will get converted into potential energy in this place, which is mg h max. So we have to find the h max, which is the height covered by it, therefore it will roll back. And we know for pure rolling motion, omega 0 is equal to v0 by r0. So here we have to equate total kinetic energy to that of potential energy. So we have total kinetic energy, which is half mv square, which is our translation kinetic energy, plus half I omega 0 square is equal to mg h max. And we know for hollow spherical ball, the moment of inertia for hollow sphere is equal to 2 by 3 mr square. Now we can substitute it. So we have half mv0 square plus half 2 by 3 mr square into omega is v0 by r0 whole square is equal to mg h max. Now which and all terms we can cancel, we can do it. So we have 2 and 2 over here, m and m over here, and we can cancel r0 and r's over here. Then we are left with half v0 square plus 1 by 3 v0 square is equal to, here the mass is also cancelled because we are cancelling mass from both the terms, and the other side mass also, equal to, we get g h max. Since we want h max only, we can take g to the other side, and we can take g as 10, and we'll have h max. Now we can substitute it. We know v0 value as 3, v0 square would be 9. So we have 9 by 2 plus 9 by 3 divided by 10 is equal to h max. We can cancel 3 over here. Now remaining we get as, we have 9 plus 6 by 2, which is 15 by 2 into 10, so we have 20, which is our in meters, our h max. Now since we are in centimeters, we can multiply 100 to it, so we'll get 15 by 20 into 100. So now we get 15 by 2, which is 7.5, 7.5 10, which is 75 centimeters. Meters, we got the answer over here. To convert into centimeters, since in our question we are asked to answer in centimeters, we multiply 100 and we'll get 15 into 2 by 100, which is 75 centimeter.